Okay. So last time we discussed about this complete architecture of Kubernetes, all the components. So any question about this architecture? And moreover, I also pull down a diagram for you to get the idea how actually container D, what is actually container D. So what we did, actually, we used the uh, Docker to run the container. So yesterday we discussed that Docker is basically a wrapper over the container D. Container D is actually the engine that is responsible to run the services inside your on your operating system. But network creation, volume, security, and its API, you can also expose the API of Docker. So authentication, all Docker Compose, whatever we did, everything is a functionality of Docker. This is designed on top of Container D. Container D will not provide you the network volume and the compose everything. So now in Kubernetes, what we will do, we will use only Container D. Volume, network, security, API, everything, security, everything will be managed by now Kubernetes. So we are just going to use this core engine. And on top of this core engine, previously we understand how Docker is using this container D. And now we are going to use this container D engine to run the containers with Kubernetes. So if we look this diagram again, so here we can see the container runtime. This is the container D, and container runtime interface, that was Docker, but this time it is a different. We will see this CRICTL is a tool. So uh, okay, so now what we decided that we have to install the Kubernetes. So this is the documentation. I will share this documentation with you. So this is the complete documentation I wrote in this notepad for the installation of the Kubernetes cluster on-prem. So right now we are starting with the master, one master and two worker nodes. Initially, we will set up this Kubernetes cluster uh, with one master node, but later on we will set up the multi-master cluster too, because you should have the multi-master cluster idea if you are running Kubernetes on-prem. So that is also imperative. So on top of these multi-master, there will be a load balancer. But right now we are going with one master and two worker nodes. And for this, we are right now using 20.04. Why I'm using this old variant? Because 22.04 I got an error. So that's why I am still using this one. But this is not an issue. We have to understand the concept of Kubernetes, not the Ubuntu. So the base operating system. So whatever the base operating system is on top of Kubernetes, what version of Kubernetes you are using, that does matter. So this is the architecture. I have these three virtual machines ready. I allocate the IPs, internet is working. So these are all the steps I wrote. This step number 1, 2, 3, everything is written. In step number 1, what we are doing, we have to load submodule, these overlay and BR net filter. These modules we have to add in our this configuration file. This is a directory where you can create any configuration file to load any type of module. And step 2, this is the system ctl.d is the file, is a directory where you can push any file, save any file that will enhance the functionality of your kernel. I mean, any kernel feature you want to enable, disable, you can put under this directory. So here what we are doing, we are enabling IPv4 forwarding and IPv6 forwarding. So what is this? Because our each worker node and master node will work also as a router to route the IP from to route the IPs from different machines for the CNI, container network interfacing. So that's why we are enabling this feature in kernel. So after adding this, we have to run this command on the runtime. Otherwise, you need to reboot the machine. And in step 3, what we are doing, Docker repository. We are enabling the Docker repository. And in Ubuntu, these two commands I just fetch from that same documentation, docs.docker.io, how to enable the Docker repository. And then what I did, apt update, every time whenever you are installing any, setting up new repository, you must have to run this command in the Ubuntu. And this command, actually, I got an error. That's why I added here. So that this was the workaround for some problem. I don't know exactly what was that. I don't remember, but this I added in the documentation. Then we just installed containerd. Yesterday I showed you multiple packages we install. On top, in parallel to containerd.io, we also installed Docker. We installed Docker Compose. But now we just concern about this container runtime engine. Okay. And then this file also need to remove. There was some problem. That's why I added here. Then we did the daemon reload and start the containerd service. Okay, so this is the container runtime engine is ready. Step 4, these steps we have to perform on all worker, all master nodes. In step 4, we have to add Kubernetes repository. So the Kubernetes repository enablement, need some some packages. So I install these packages, and these two commands actually enable the Docker repository, sorry, Kubernetes repository. And this is the key, for the repo in the concept in the Linux, for the repository, there is a concept of key for the verification of your packages you are downloading. So this key is also added, and you can see this URL is pointing to Google. This is the PKGS K8IO, K8SIO. This URL is basically provided by Google. Okay, and I used 1.28 for the Debian based. So I believe nowadays its variant is updated. From latest variant is 1.30. So we need to change this. Okay, then step 5, we have to disable swap. Swap should be off on all servers, worker and master nodes. So this with these commands, we disable the swap. We remove the entry from FS tab and did the swap off. Step 6, we install the Kubernetes. So we in step 4, we enable the repository. Step 6, we update apt update and we install kubelet, kubeadm, kubectl, and Kubernetes CNI. These 3 packages we have to install. And kubectl is the administrative command for the Kubernetes. It is not mandatory. If you want to administrate your Kubernetes cluster from the master node, then this command you need. Actually, this command you need from the machine from where you are going to manage your cluster. And kubectl is mandatory. It is provisioning the whole Kubernetes cluster. A lot of things it will do. I will explain in the rest of the course. Kubelet, kubelet is this engine that we see yesterday. This is the kubelet. So kubelet is a core engine on every worker and master node to interact with the API. Okay, and Kubernetes CNI stands for Container Network Interfacing, mean the IP table rules that we will use to expose the To mean this tool, this package will provide the functionality to manage the, you can say, the IP table rules, and how those IP table rules will then later on expose the application to the external world for the end user by using kube proxy. We have to understand this. So okay, and then what we did, this APK mark hold. Hold mean in Linux, if you want to hold mean due accidental deletion, mean uninstallation of these packages can cause the failure of your cluster. So we hold these packages. Nobody can uninstall it until you will run the command APK mark unhold. And then we are exposing an environment variable. This variable is not mandatory. Either you can use this step to pull the latest version of Kubernetes. What repository you enable? I enable the repository v1.28. Right now, latest version is 1.30. So, or you can, if you want to use some older version of Kubernetes, then you will expose this environment variable with the desired version of your Kubernetes, and then you will install the kubelet and kubeadm and kubectl and Kubernetes CNI along with this environment variable. So the older version, whatever version you provide here, will will pass here as a variable, and it will pull those relevant packages only. Okay, so we will use these first three lines because we want to use the latest version. And step 7, we install the containerd. We have to restart the containerd service. Uh, then this step is only for master node. Okay, so first of all, these 6 steps, if you do these 6 steps one by one, it will take too much time. So what I did, I create a single script up to up to step number 6. So all the commands I push here. I mean, if you compare all these commands with the documentation, you can get the idea. So all the files are creating here, same things. But just like if I can show you the how I disable the swap. So with this command, I remove the uh, swap entry from the FS tab. Okay, and uh, then I move the this file to back to the original position. Then swap offer and everything I have done. So what I will do, I will just copy this script on each master and worker node. I will simply run it. It will perform everything. Internet should be up and running because it will pull a lot of packages. So let me start my virtual machines. I created 3 worker nodes because I have more RAM, but you can do with the 2 only if you have less resources. Actually, the bottleneck is my disk. Actually, this disk where I am writing, it's a magnetic disk, not SSD. So that's why it's taking time.
Okay, one question. Can we use Ubuntu desktop flavor for worker node, or we need to install the Ubuntu server for worker node as well?
No, only server variant.
Okay.
Okay. So my master one, I set up the machine name VU-M1. Okay. And I will switch to as a root user, and I have to upload this script on in this machine. So actually, I was logged in as a non-root user, so this file is directly uploaded in the home directory. Yes, yeah. So what I did, I just copy the script file to my root user home directory. Right now, I'm root user. So what I did, I just copy the script and I ran the script. Okay, and let's see what happened with this script. Okay, I will install this 1.28 version because we have a lab to upgrade the Kubernetes version. So we will update from 1.28 to 1.29 and 1.30. So meanwhile, to save the time, I will start the installation on worker nodes too.
So to run this script, we should be in the root home directory. I mean, we need to copy this script file on the root home directory, or we can copy it anywhere.
Anywhere,
Okay.
no issue. Anywhere you can. Okay, so this script is completed on master node. Rest of all will be. So, okay, so now up to step number 6, all tasks are done. Now what I have, if I go to my master node, I can see I have cube Atom, kubectl, and kubelet, all three, uh, all three commands. So now on the master node, what I wrote in at the end of the script, you get a message. Now run cube Atom init on master to set up the control plane. So you will run this cube Atom init command on the machine that you want to declare as a master. So this machine will work as a control plane. All these components, the API, controller manager, scheduler, etcd will run on the machine that is set up with kube Atom init. Uh, if we go back to the documentation, I also mentioned here, simply you will run kube Atom init only on master node, only on one master node if you want to set up only one master node. But if you want to set up multi-master, so then this command will be different. So right now we are using only single master. When you will understand all the components, then you can easily understand what are these additional parameters. So here we are defining some the IP of the API endpoint control plane. This will be actually the IP of load balancer in case of multi-master. But uh, in a single master, the master node IP will directly use as a as a API. So upload certificate, asserts, and these are all the things that we will discuss in detail. And so right now we are just going to run kube Atom init. We can customize multiple things, but right now I don't want to confuse you. We will set up the cluster with the default setting. What are those default setting? We will discuss.
So if we
Right
are,
now, mm,
sorry,
yeah, yeah, please.
if we are initially using one master node and we need to upgrade it to multi-master, then can we use only second command? I mean, for multi-master node, or we need to just add the simply parameters?
No, this is not only the command. Actually, you need to do additional homework for the multi-master. You need to set up the load balancer. First, you will set up the load balancer, then you will run this command. And how to set up that load balancer? You can do load balancer setup on the hardware level, or you can run the HA proxy on Linux level. So we will do this on the, we will set up a Linux machine to provide all the load balancing functionality.
But
So,
if we
but
are
if you
running,
run,
yeah, but if we are running a single master node, and then later on we decide that we need to run a multi-master node, then obviously we need to configure first the load balancer, and then we need to configure the multi-master.
yes,
So what
otherwise
we,
your communication will not work. Yes.
yeah, so what we need to do, I mean, do we need to use the same master node, or we need to create a new master node for multi-master node?
No, no, definitely you need to create two more master node. We have
No,
right now only
two
one
more,
master
but
node.
yes, two
Hmm.
more, but the initially the single master node what we are using already. Can we use the same master node for multi-master?
Yes, yes, we can use. We can use, but
Okay,
in that
okay.
case, we have to customize that some configurations, because right
On the
now
same master node, right?
on the same master node, because right now what we are writing with this command, I will show you when this command will be completed. I will explain you everything what is happening here.
Okay,
So
thank you.
Yeah, very first output you can see here, it is giving you a message that the latest Kubernetes version is 1.301. But what repository I enabled 1.28. Okay, so I can go up to this version latest. And right now, what version will install 1.28.10 and running pre-flight checks. Pulling images required for setting up Kubernetes cluster. What are these images? So for this, you again need to understand this diagram. API server, controller manager, scheduler, etcd. These four components on the master node on the control plane will run in the form of container, in the form of pod. Inside the pod, they will run as a in the form of container. These are not the straightforward services, just like we are using in the Linux machine. Okay, so these will be in the form of microservices. So that's why it is pulling all these four core components for the master node on the on this master node where we ran the kubenet command. So you can see this might take a minute or two depending on the speed of your internet connection. You can also perform this action in beforehand using when we just install the kubeatom command. We can simply run this command too, just to pull down all the required images for API server, for controller manager, for scheduler, for etcd. It will only pull down all the required packages. So in that case, it will take less time when we'll do the init. Okay. The what services will not run as what services will not run as uh, under the container and not as a microservice. Only two services. One is kubelet. This will not run in the form of microservice. And the container runtime engine. This has to provide the container running functionality, that is container d.io installed. So this will run as a core service on the operating system. We will start this with the systemctl start command for the kubelet and container.io. And we install this. If you look in the documentation, we in this step, we install this package. Okay. And in this step, we install kubelet. So these two will run as a service on the Linux operating system, not as a microservice. The rest of all component will run as a microservice. So now uh,
So wherever we are setting up the Kubernetes cluster, we can run this script up to the six steps.
yes, you can. Only difference can be because this container runtime engine, I use container d.io. So maybe you need to run different container runtime engine. So in that case, you will just change this. So that need a different repository, different package to install, just like Podman from Red Hat. So to understand the concept, even in the practical life, this container.io is used. And okay, so what we discuss, image pull. Okay, detected the sandbox images, the container runtime in inconsistency stat that the Kubernetes recommended you use a registry 3.9 as a CRI sandbox image. I don't know exactly what is this saying, but this is not a problem. This is just a message. Uh, Using certificate directory folder. So in this directory, it will create all the certificates, the SSL certificates, because all these components of the Kubernetes, API, controller manager, scheduler, etcd, and kubelet, These all red arrows will communicate over the TLS, transport layer security, using SSL, some certificates. So for this reason, it will create its own certificate authority. You know what is certificate authority? Anyone can explain? Anyone have idea about the what is certificate authority?
Yes, it's basically you can say maybe you can call it a server where you install the certificates, where you revoke the certificates, where you renew the certificates. The
Hmm.
server basically
Yes,
used for managing the certificates.
yes, we can for signing the certificate. Normally, in our practical life, when we host a website, we purchase a certificate from some signing authority, just like GoDaddy or Let's Encrypt, or a lot of other signing authorities are available online. But if you are running a local environment, you can set up your own signing authority. So this is a certificate authority. So under this certificate authority, we will provision the SSL certificate for all these four services: API, scheduler, controller manager, and etcd. Now you can see the generating API server certificate and key. When you generate a certificate, there is a key and a certificate. So certificate, public certificate is used for the to access the service remotely when you are opening a website on HTTPS based. So actually, the public certificate is used on your browser, and the private certificate is deployed on your server side. So API has these two keys. An API server cert is being signed for DNS name. So whenever you are signing some certificates, so you must have to provide the DNS name. So this certificate is signed for all these names: Kubernetes, Kubernetes.default, Kubernetes server default.svc, Kubernetes default.svc.cluster.local, and the host name of this master node. Uh, when you set up the Kubernetes cluster, there is a domain name by default created for this cluster, and its domain name is, by default domain name is cluster.local. You can change this domain name for your own purpose too, but by default, so far I just ran the kubectl init. Kubectl init basically use the default setting and use the cluster.local domain. uh, then these two IPs. So you can call the API server by using these two IPs. This is my host machine IP, what I used for this machine, master one. And this IP is an additional IP. We will understand this. Basically, this is a service IP. This is, you can say, something related to kube proxy. Then generating API server kubelet client certificate and key. Now this kubelet, this kubelet is also running here on master node. This container runtime is also running on the master node. It is not showed here in this diagram. Every worker in master node will have kubelet and container runtime engine, because all these components are also running under the pod. So kubelet and front end proxy certificate authority, certificates and key mean the proxy we will use to communicate, a proxy server that will be used to expose the service to the external network. A front proxy client, this is related to proxy certificates. Then etcd database certificate, it has its own certificate authority, and its certificate and key. And then etcd server, this is the certificate authority setup, and this here it's set up, it does the signing of the certificate for the etcd, and the host name used for the etcd database, localhost, and the machine name, and these IPs will be used. And then etcd peer, peer is when you are running multi-master. So etcd database has to communicate with each other. So this certificate is used to make the communication among multiple etcd databases in multi-master mode. Okay, so this is all story about the etcd, the domain name, and then etcd health check client certificate and key. This is some another certificate is generated for the health check. When the multi-master node will run, etcd will do the handshaking to see the status of each database. API server etcd client mean when the API server will communicate. This API server you can see is communicating with etcd. So the public certificate will used by the API server is this one. Okay, and then SA key and public key. I don't know what is this exactly. Using kubeconfig folder. Then this is creating this directory, and under this directory, it is creating some very imperative configuration files: admin.conf, kubelet.conf, controller manager, scheduler. These are all the configuration file. We will see this in our rest of the course. And this is very important directory where all the manifest for all these core components of the master node, etcd, scheduler, API, and control manager. All the manifests are going under this directory. And you can see the pod manifest for API, controller manager, scheduler is created here. And the configuration file for this is also created here. Okay, and now it is starting the kubelet service. You see here creating static pod. For the API server, controller manager, scheduler, it use the pod word, a pod to start as a service in the form of container, but for kubelet as a base operating system service. Okay, and then waiting for the kubelet to boot up a control plane as a static pod and a directory etcd. So now kubelet actually took about 4 milliseconds, 4 minutes 0 seconds to uh, start up. All control plane component are healthy, mean all these components. Sorry, I think I shared the wrong screen. Okay, so all these components, core component of the cluster are in healthy state. And config map, this is config map we will discuss. This is the configuration. If we want to throw some configuration inside the pod, the config map is created. And skipping phase upload certs. Uh, this label is attached with this master node. What are these labels we will discuss, and what else it did? Configuring bootstrap token. Yes, bootstrap token, config map, role-based access control, cluster info, everything is ready. And this is something related to security. We will perform these labs. And creating the cluster info under the config map, cube public. This is the configuration. This whole cluster configuration is preserved under this config map. What is config map? This is a resource of the Kubernetes to save the configurations. Uh, this is the kubelet configuration file that it started as a system service. Then the DNS, because pod to pod communication is not by IP, so it will be by name. And when you will communicate pod to pod, so the name will be fully qualified domain name, and what this cluster domain is cluster.local. So it will be like this. So when you will communicate pod to pod, this fully qualified domain name will use. So DNS is ready. And then kube proxy is ready. This one, this kube proxy that is actually responsible to write the IP table rules to expose the pod service outside the cluster. Everything is ready, successful, done. And now it is suggesting us to perform these three steps. Create this directory and copy this file under this location and change the ownership of this file. What is this file actually? So when we have to interact to the API as an admin. So yesterday we discussed this concept in very detail that you cannot directly interact with the API. You need security. I mean, everybody cannot interact with your cluster API. So there is a token-based authentication, and uh, that authentication is token-based, and that whole token story detail is written in this config file. Okay, if I open this file, you will see. I will show you that how this token is generated and what user will be used to log in into the Kubernetes cluster. Alternatively, if a root user, you can also run. Either you have to copy this file that contains the token and the API URL of the Kubernetes cluster uh, to this location from where you are administrating the Kubernetes cluster. So initially, I will use this master node to administrate this cluster. Otherwise, I can install the kubectl utility on my Windows or Linux or any other machine that can reach to API server, and I can provide this config file that holds the token to for the authentication purpose. So in that case, I can also do this. Either I have to place this uh, Adam file in Linux under any user home directory in directory hidden directory .cube with this name, or if I copy this config file with some different name or at some different location, then what I do? I need to expose an environment variable, and whenever I will run the kubectl command, it will uh, follow this environment variable, and this environment variable will acknowledge uh, that where is this configuration file is exactly. So what I will use this method. Uh, this file is already there. I will just expose this kubeconfig environment variable. And if I run env, now I can see the kubeconfig environment variable is exposed. And the path of this config file is mentioned. OK. And you should now deploy a pod network to the cluster. Kubectl apply -f. OK, this is actually, it is saying that right now your cluster does not contain any CNI, CDN, any virtual switching infrastructure. Right now, if I open this diagram again, this arrow, plugin network, Flannel, ViewNet, Calico, Cilium, we discussed yesterday. So this will be the virtual switch on your each worker and master node. So far, we have not deployed any third-party vendor this virtual network. You can see pod network. But how the pod will get the IP and how the pods will communicate with each other, it is not deployed. It is saying, it is suggesting us to run the manifest of that vendor on this machine by using this command. So this will deploy your virtual switching network. So we will do this, and it is giving you the documentation, what is cluster administration add-ins. You can join any number of worker node by running the following on each as root. Now, if you have, this is the master node ready. OK. And now if I want to join any other machine that can reach to this master node. So I can use this whole token. This is cube Adam join. This is the IP of this machine, and this 6443 is a port of the API server. I will again open this diagram. This admin user is sending request to this API by using 6443. So 6443 is the default port for the API. And then this token will use to for the as an authentication. So now what I will do, I will straightforward go to my worker node and I will just copy paste this token information on my worker node. And now my worker node is communicating with this IP on this port to API by using this token. This token is the basically authentication mechanism. Mean I want to join you as a worker node. So running pre-flight checks and what actually this whole process did at the end of this whole configuration, it started this kubelet service. This kubelet service is now started on worker node, and it start communication with API server. And now master node knows that I have one worker node. Okay, so from the master node, cube kubectl is the command to administrate the cluster. Kubectl get nodes command if I run, I can see how many nodes I have. I have this node that its state is not ready and its role is control plane. Mean this node is responsible to run API, scheduler, controller manager, and etcd. 21 minutes ago, it was running this version of Kubernetes is running on this one. And one worker node is attached. Its role is none. Mean it's not working as a control plane. It will not run any API server, etcd, scheduler, anything. It will only run the application load. And its state is not ready. Why this is not ready? Because uh, the virtual network vendor product any Calico or ViewNet we have not deployed so far because pods are not able to get the IP from any network defined interfacing. This layer is not completed yet. So let me join with the same token this second worker node. What happened? Accept at most argument. I think 2 greater than. I think this greater than is. This greater than is not required. Yes.
This token has been generated by master node.
Yes. Now, if you run the kubectl get nodes, you can see 2 worker node and one master node is ready. I mean, attached with this master node, but not in ready state. Okay, if we go back to the documentation, if we go back to documentation and we see step 8, I explained you in detail what is this configuration file. Okay, let me show you this configuration file now. So this configuration file, if I do, my thing will show me in color format. No. Okay, actually this file is the configuration file. You can say this file is the just working just like a credential, username and password authentication mechanism to connect with your cluster. So API variant V1, this is its own syntax. Then cluster, this is the certificate authority data. This is the CA, because this is not certificate authority. It came from some signing authority that is available online. That's why this file contains the whole data about the signing authority. So that when the certificate will be SSL communication will happen, it will not give us the error that certificate is not signed. So this whole signing authority detail is mentioned here. Then where is our API server? So this is our API server. On this server HTTPS, we have to send request and on this port. And what is the name of the name? Kubernetes context. We will discuss this section when we will create our own user, own certificate to communicate with the cluster. What is this context? And kind is config user. This is the user. Kubernetes admin is the user. That is the full administrator of this cluster. And this Kubernetes admin user will log in by using this client certificate data and client key data. This is, you can say, is acting, will generate the token to interact with this API. Okay. And so this is the story of this config file. So this file is very critical. You have to save this file uh, some location where if anyone get access to this file, they can access your cluster if they have the reachability to this URL. Anyone got access to this file and have access to this IP over this port, they can do anything on your cluster because this file will make that user administrator. So right now, when I ran this command, kubectl get nodes. So I am interacting with this cluster from here as an admin user. Okay. And I am communicating to API using transport layer security and by using this token, what is provided. And whenever I ran this command and this answer came, actually kubectl will check this environment variable. And what value is given to this environment variable will answer the authentication to fetch the data from the cluster. So this answer came actually from the API server. And API server actually asked from where? Actually, API server asked from etcd. So all the worker node details, master node details are saved in the key value format in this etcd database. Okay, so let me just do one thing. Let me export a wrong variable. Export kubeconfig. For example, I define a wrong variable name. Some file.txt. This file does not exist on my machine. And when I will run kubectl get nodes, will give me the error. What is this error? Just read this error. It is trying to connect with the API and API response refused. Because I mean, it is not even able to reach to the API. By default, it is trying to hit this URL. Because even the API URL is provided by this file. Even the API URL is provided by this file. So now kubelet don't know from where we have to fetch the data and where we have to send our request. So now it is communicating with the cluster. Okay, so This kubelet we don't need on the master node. In worst case scenario, I mean we don't have any client, then we will use. We will install this kubelet client on our Windows machine, on any other Linux machine that can reach to the API server, can interact with the cluster. Just like if I open my CMD, what I did, I installed this kubelet command. Kubectl, I think I have get nodes. I will get the error. Why? Because my Windows machine environment variable, same like the environment variable I set up in my Linux machine, my Windows machine environment variable does not contain kubeconfig value and does not contain this admin.conf file. So what I will do, first of all, I need to download this file. I will copy this file to uh, for example, I downloaded in C drive. Okay, desktop. So this file is downloaded on my desktop. This file. I think of mobile extreme. Permission error, because I copied from root user to the root, and I am downloading by the non-root user permission. So I must have to set ownership to ch on. Now I can download it. Now this file is downloaded on my desktop. So when I am running this kubectl command, how you can install this kubectl command on Windows? You can directly go to Google and search how to install kubectl on Windows. It will give you a package, some exe installer. You just need to run that installer that will enable the kubectl utility on your Windows. If you are using MacBook, you can install in your Mac too. If you are using Linux, for the Linux, you need to enable the repository and you can install. You can find all the documentation online. That's not a difficult job. So now what I have to tell this Windows machine. Yes, I already declared this environment variable. I was working on something different. Yes. So now browse file. From desktop, I want to use admin.conf. This admin.conf I've recently created. And I need to close this CMD. I will open a new CMD and here kubectl get nodes. Yes, now kubectl got the environment variable, and it now I can manage my whole cluster from my Windows machine. So CMD is a difficult tool. It is not providing you rich functionality. So MobaXterm is a good tool. If you open a new session, actually MobaXterm is providing you the shell same like Linux. So whatever Linux command, Windows command are available, you can use here. Kubectl get nodes should work here. No, actually my MobaXterm I need to close and open again because I declared the environment variable and then it will fetch the new variable. I cannot do right now. It will close all my session. What else I can use? I also have Git bash. You can install Git, and it is also providing you the terminal just like Linux. Here you can use vim, everything. You will cat more, all the commands will work here. So this will make your working environment very easy. So if I type here kubectl, this is basically exe in Windows, get nodes, so it is interactive. So either you can use this tool or Mopa Extern, both are good. So any questions so far? Right now, what is the situation? Situation is our master work cluster is ready, but it is not in ready state.
So
So
how
any
to
question?
keep this
Mhm.
admin conf file secure? I mean, what we can do to secure, as you said that this file is very critical, and if anybody has access to this file, he can access your whole cluster. So what is the remedy? What is the method to secure this file?
You can put in some vault this file, or in Windows you can do the drive level encryption, or the permission, whatever you can use. A lot of things. Same thing, same config file will be provided by the cloud. When you will set up the Kubernetes cluster in cloud, they will provide you this config file that contains the administrative level access of the cluster, token, user, everything. Okay, so now we are going to take just a 5-minute break, and after break we will make this node ready state to ready, and we have to deploy the some network plugin so that our pod will be reachable. We have to also perform some cluster administration related task. Okay, we can resume now. Can you hear me? Can you hear me?
Yes, we can hear you. Thank you.
Okay. So uh, our basic cluster is ready with the two worker node, one master node. So now we have to install some network plugin. So ViewNet is the simplest network plugin we can install, and its manifest. It's an open source project, and its manifest available on this version 2.81. I don't know exactly if its latest version is available now. Let me just check if I can. No, it will not work. But actually, I have this version. No problem, it will work. So what I am doing, I am just downloading the manifest that contain what pods and what services need to run this file on my anywhere I can download here. So wget is not a command. This is not a Windows command. I think I can download on my master node directly. So this ViewNet daemon set key 8SYML file downloaded. This contain all the details. Right now you will not understand what is this file doing. Just remember this step. Okay, so now this manifest will apply some new pods that will provide the network functionality on each worker node, each master node. And now if I get the kubectl get uh, nodes, so you can see it's in ready state. So what happened exactly right now, our network is ready. And so our cluster is now ready. So now we have to understand some basic concept of the Kubernetes cluster, how resources will work, and how we will deploy our application. So actually, there is a concept of namespaces in Kubernetes. This namespace is different than the namespaces we learn in container. That is the core functionality of Linux kernel. This namespace is, if I type here kubectl get ns or namespac namespace. So this is basically a logical division of your resources. Whatever application you will deploy in a separate namespace. So each namespace will contain its own set of resources. So it will make the management of the resources easy if you want to delete the whole project or migrate the whole project. That will help by the namespace. So right now, Kubernetes is providing me 4 namespaces. Uh, these all 3 namespaces are empty. Default, kube node lease, and kube public. It does not contain any resource. But this kube system is very important. It contains all the pods that ran under this for the Kubernetes control plane services. So kubectl get pods, okay, hyphen n, the name of the namespace. I can see these are all the pods running in kube system namespace. If I run without any namespace, it is saying no resource found in default. So when you are not defining the namespace with -n, it is by default pointing to the default namespace. Okay, so but if you want to get some thing from different namespace, you must have to define the namespace with -n and the namespace name. So now these are the core components we discuss in detail. So this is the etcd database, and it's in running state. It ready state is 1 out of 1. 1 out of 1 mean this pod has this etcd vu-m1 pod has one container, and 1 out of 1 is up and running. Then API server pod has one container, and 1 out of 1 is up and running. And then controller manager, 1 out of 1 is up and running. And this is the kube proxy. It is running on all uh, across the cluster. This is on master, this is on worker 1, this is worker 2. And this is the scaler. This is only running on master. I will show you how you can see which pod is running on which node. And this is the virtual switch running on each worker and master node. We have 2 worker, 1 master, 3 virtual switches are running. Okay, so and this is the core DNS. 2 pods are running for core DNS that will help to resolve the name to IP when you will interact from pod to different pod. So the name to IP resolution will be done by this DNS running inside the container in the pod. Okay, so all these services you can see, and if we run the same command with -o wide, -o wide will show you the additional information of all these pods. I am just, you can see this again. I need to more. Yes, now it's good. So you can see the core DNS pod. This is the name of the core DNS running state, 0 time restarts 53 minutes ago. Its IP is this. This is the IP of the pod. And on which node it is running, both pods are running on worker 2. Okay, and etcd is running on master, kube API is running on master, controller manager on master, proxy is running on each machine, master and worker 1, worker 2, and scaler is running on uh, master node, and weavenet is running. Each pod is performing the virtual switch functionality. This will provide the IP to the pod. So these IPs to this core DNS pod is actually provided by this switch that is running on, this switch that is running on our master node. So whatever pod will, it's worker 2. Worker 2 virtual switch provide IP to these 2 pods because these two pods are running on worker 2. Okay, so when you will run these pods on different worker node, it will get a different series of IPs. So this IP scheme is different than the IP scheme we have on our physical machines, master and worker nodes. And the different thing you can see here, all the etcd, these core components are not getting the IPs like this from this virtual networking, from this CNI. It is getting this pod is using IP of the host machine. So this we will also look this thing that how this pod is using the host machine IP uh, to allocate to the this pod directly, because these services should not be dependent on this virtual network interfacing. This this layer, plugin network. So these services are not coming under this plugin network. They are getting IP as same like the IP of the host machine. Okay. So if this service is running on worker one, so worker one IP is this, worker two IP is this. Okay. So so when so
Question.
why yes, please.
Yeah, two or three questions here. So first of all, the core DNS, why this is not populated by the master node, uh, and why they choose the worker node
Because
too?
this service is not responsibility of control plane. This is an additional service just to provide the name to IP resolution. Mean your cluster will not in degraded state when DNS is not running. Mean your control plane will not be in degraded state.
No,
So that,
the code the code DNS definition is the where we have the host to name to IP resolution, right? This one is the
name to IP resolution only for pod to pod communication, not for the host machine's communication.
okay. Number second, these IPs 192.16, these are all dynamic IPs, right?
No, no, no. This IP came from my host machine. This IP is my host machine.
Means if the pod uh, if the pod what can say we crashed, or the operating system is crashed, or pod itself crashed, then this IP will be loose, right? Or what?
No, no, no. This IP is not dependent. This IP is not coming from the container. This IP is coming from the host machine. Only these pods will get the IP from the host machine. Rest of all, our own pods, our own services will get the IP from a different IP range. Whatever our virtual switches we created our each worker node and master node. This virtual switch will provide a different IP scheme range. Okay, this will be different from this one.
Okay, I got it.
And
Sorry. So this IP is the worker node, not of the pods.
yeah, this no, no, actually this is the IP of the pod, but this pod is a special pod, and this pod is configured specially to get the IP from the host machine. Why?
Yeah,
What is the reason? What is the reason? The reason
yeah.
is if your virtual network interfacing tool is down, still you can communicate with the API. You know, when I have not deployed the VivNet, but still I was able to talk with the API server. How? Because my pod get the IP same like my host IP. So that's why my communication was possible. If I am 100% dependent for all these pods to be assigned by IP by the this network plugin, then network plugin without network plugin I cannot communicate with these services. So these services are not dependent on network plugin. Simple answer is this.
Okay. And the worker node, in the worker node we have many pods, right?
Now,
We have
which worker node?
any for example, worker node, we can create many pods, and every
Hmm.
pod have the unique IP address.
No, not every pod. Each worker node will get a specific range of IP, uh, and all the pods, if on a same worker node, will get the IP from same series. Second server will get the different network series IPs. So you can see these two pods are on the worker two. That's why they are getting the same range IP. So
Okay.
when I
So
will reply the some pod on worker one or then you will we will get the different IP.
okay, then as last lecture we have discussed that the pod IP never populated because to the security reason. And here in our case, the 10.30 IP is showing us, and
10.30, where is 10.30?
the top two worker node.
10.38, yes. No, you can see the IP. It's not a security concern because you cannot reach this IP from the external network. This is only reachable from within the cluster. Only you can reach these IPs from the external network so far.
Okay, is it possible if the worker node? Uh, so we have worker node 1 and we have worker node 2. Worker node 1 and the pod under the pod we have the IP 10.38.0.1, and the worker node 2 and the pod under the pod that has the same IP, that 10.38.0.1.
No.
Can configure?
Worker node 1 will have the different IP. I will deploy the pod, that you will get the better idea. Let me quickly deploy a pod.
Sure.
For example, I want to deploy a pod. kubectl run is the command to deploy a pod, and I want to deploy a pod with name Yasser. Okay, and what image I want to use, Nginx. Okay, so by default it will pull the image from just like this docker.io/nginx. So if I am not defining, it is directly going to docker.io repository. Okay, and I simply ran this command, and you can see pod Yasir created. And in which namespace it's created? In the default namespace. Otherwise, I need to define the namespace here. So by default, when you are not defining the namespace, it will go in the default namespace. So if I run kubectl again, get namespace, this is the default namespace, okay? And if I do kubectl get pods, -n default is not mandatory, but just for your concept, I'm writing here. You can see Yasir pod is running. And one container out of one, because we just load one container in this pod. So 1 out of 1 is ready in 36 seconds. And if I run -o wide, I can see it is on worker node 1. Okay, let me again run another pod. Yes, to Nginx. Okay. Now the request, just recall the same concept. Request as an admin, go to API. API asked the scheduler. Scheduler said Yasser will go to worker 1. Now let's see scheduler what decided. Where I was reading, yeah, here. So get pods, default namespace. This is also running on worker 1. Okay, let me load another pod. For example, app 1. I am using this time HTTPD and app 2. Tomcat. So it is saying creating container. It means it's trying to pull. If you want to see the real-time status, -w will do the watch, the real-time status update. So you can see the app 1 is running on worker 1, app 2 is running on worker 2, and this is also on worker 1. So all worker 1 got the IP from the same range. And it will get the IP from 38 series. Just that was from the core DNS, because this is worker 2. It is basically taking time to pull the image. Tomcat is heavy. That's why it will be ready in a while. So each switch, virtual switch placed on each worker node, you can see now the pod is up, and it got the IP from the virtual network 38 series. So now if I run get pod -o wide, So this this IP is different than these three IPs. So I just simply ran some pods that use the simple one image and in the default namespace, and it is automatically collected with the virtual network, and it is automatically scheduler decide the to distribute the load among the across the whole cluster. Are you clear? Any question?
Yeah. And these IPs are the if 0.4 want to communicate dot 38.0.3, app one
Yes, it
want
will
to
do. It will. It will. I will show you, but another thing that I have to explain you, your question should be mean who decides this IP range? How we decide? So when we did this, we did this kubectl, no kube atom. We did kube atom init blindly. Press enter. We should not do like this in practical life. We should do like this. In the help, you can see a lot of configuration you can customize. Just like mm, just like service, you can see. So I can do something like this cube atom init service seeder, and then equals to I will provide the IP range for the service. What is service? That is different thing. That is not the pod IP range, but service IP range is different. We have not discussed this so far. And similarly, the domain name for the cluster we can define with this is parameter. Okay, and there will be something. There will be something. Grep pod. Yeah, pod network seeder. So these all customization you can do, and you see if set, the control plane will automatically allocate seeder for every node. So we have to provide with this parameter a big range of IP that will be further divided into small subnets for each worker node. So now there is kubectl get config maps. Config maps are basically a resource of the Kubernetes cluster that provide the configuration storage. So by default, this config map is available in this default namespace. If I go in kube system, so kube system, previously I query to pod, now I am querying to config map, and config map holds all the configuration for different pods. These config maps are associated with different pods. So core DNS configuration is here, API authentication, and the answer of your question is kubelet or kube atom, I think. So if we want to see what is actually written in this config map, kubectl describe config map. This is the config map name in this namespace. So yes, this config map holds the configuration. You can see, this is the service subnet. This is not about the seeder. This is the cluster domain. This is a cluster variant. Okay, so I think if we get config map, describe config map, kube atom config, kubelet config. This is the DNS IP, okay, and I don't remember exactly where is that. I think ViewNet.
VNet is also the functionality of the netting, right?
Yeah, netting.
Okay,
Yeah, and the communication among the pods. No,
good.
this is something different. But there is a some setting, I don't remember exactly where is that. For example, core DNS. Let me just see this. These are all the configuration. In Kubernetes cluster, you will not save your configuration files straightforward in the config form in that state of file. You will dump every file in config map resource, and that will go straightforward inside your etcd database. This everything that I am fetching is coming from etcd database. Okay, so this right now, what is happening here, I will show you the routing table now on
Yeah.
each worker node. So if I type here, you can see multiple virtual interfaces created. So whatever, same like Docker, whatever which new container will launch on this worker node, it will be, it will create its own interface. And now you can see this IP /12 defined by VNet. Okay, this IP range is for this worker node, and same IP we saw for the pods running on this worker node. And if we type here IPA, this is we've its range is this 38. Okay, and whatever pods are running on this one are getting their interface. And if I type here IP space route, so this is a routing table. And you can see in the routing table what is written. If you want to reach, it has 38 subnet. If you
Mm.
want to reach to 32, you have to follow this Weave device as a gateway. Okay.
Okay.
To reach this subnet, by using this subnet, either you can define the gateway IP or the device name. So all the traffic that this machine worker node 2 will generate for this subnet will be routed to this interface, and this interface will then route the traffic to the next worker node. And here you can see VXLAN. This is the VXLAN VPN encrypted tunnel, layer 2 tunneling protocol it is using to connect the both worker nodes. If I draw the diagram, so this is the whole static routes, everything is added by the container network interface we deployed,
Mm.
network plugin. So what happened, we have actually 3 worker nodes. I will show you the static route on master node 2. Let me show you the master node 2 IP routes. Yeah, if you want to reach to this subnet, you can go to this Weave device. Route -n is old command. No, it is not installed. Just I think it will show you something like which gateway you can follow. Mm, no, it is again using interface. It is sending everything to this interface, and has uh, each node has VXLAN interface. This one, this one, and 6784, 6784, and it's also 6784. You know VXLAN, what is VXLAN? So these are,
Mm.
for example, 2 worker node or 3 we have. And what is happened? Yeah, a virtual switch created here by ViewNet, a virtual switch created here, and by using the physical interface, for example, this is physical interface, this is physical interface, and by using the physical interface, it create a VXLAN in virtual interface that is making bridging over this physical interface. So this VXLAN is actually working as an uplink for this switch, and this is using this physical interface as bridge. This is also using physical interface as bridge and uplink for this switch. And this VXLAN is making tunnel across this uh, these two worker nodes. So if these two worker nodes are connected with across the different network, you got the idea? If there is some router in between these two worker nodes, so then what is the benefit of VXLAN or VPN tunnel? It will make your communication on layer 2. End-to-end communication will be possible. No routing, outside routing will affect the internal routing. So for example, you launch a pod here. Okay, you launch pods here. These pods are connected with this virtual net switch. This is connected with this virtual switch. And they are getting IP by DHCP from this virtual switch. And here in our situation, we have 10.32.0.0/12. I think it was slash 12, yes. And here we had 10.32.0.0
38.
slash 38, sorry, 38/12. So these two subnets are reachable by its static route. So think like if VXLAN is not there, how this routing will happen? It is not possible.
So,
So
so
whenever, hmm,
mhm.
yes,
Actually, before the VXLAN, we use the inter-VLAN communication. So we have the router and we put the VLANs in VLAN. Let's say VLAN 10 and VLAN 20 wants to communicate with the internet inter-VLAN communication. But here if we put the router, then it will convert to the inter-VLAN communication. But why we put VXLAN means VXLAN it
VXLAN
connect.
is
Okay,
actually
okay.
VXLAN is just like a VPN tunnel.
Not understand. VPN tunnel. Can you
You can
please
say
more elaborate?
just like a VPN tunnel. It will extend your layer 2 connectivity. Simply.
Okay, okay. So if on the left side we have the VLAN 2 and the right side we have the VLAN 2. Means both, but the network are different. So they will. What is the concept of the side to side VPN? As you know, we have the some subnets are here and some subnets are there. And side A have some subnets, side B have some subnets, even
Hmm.
same subnets. So that's on the VPN concentrator or VPN, any VPN device that will basically do the netting. So in this case, the viewer basically perform the netting or yeah.
Side to side, whenever you are configuring side to side VPN, you will use a different network on each side. Is this true?
Yeah, true, but we can use the same subnet as well. No,
Hmm.
because your organization, maybe my organization, your organization using the 192.198 subnet, 192 to 168, and my organization using the same subnet, and we cannot say that oh Asim, you are change your all network. No, so we will do the some there is the we will do the netting actually, source based net actually. we will perform
No,
there.
no. In VPN, yeah, then you will use the netting. But if you want to direct make the communication with using the routing protocol, using the VPN tunnel, then you must have to use the different subnet. Just think this case. This is happening the routing across the two worker nodes, and both are using different subnets. So each pod will get the IP from its own subnet, and it will be routed when the pod will send the traffic to its gateway, to this switch. So this switch will use this static route to route the traffic to the other network. When I will
No,
launch a third worker node, I will see another static route here. So far, I have only two worker nodes. That's why I can see only one static route.
yeah, this is straightforward. My confusion is actually where my confusion is VXLAN. So where uh, if let's say 10.40.0.0, they are doing the
Mhm.
static net. Yeah, this is okay for me. So VLAN, as you told, the both VLAN, that is the VPN tunnel, right? So VPN
No, no,
tunnel
it's
in this.
not VLAN. It's VXLAN.
No, sorry, yeah, VXLAN. That is
Yeah, it's V. If you look the definition of
Virtual
VXLAN,
virtual extend virtual extend extensible LAN. Virtual extensible LAN.
virtually extendable LAN mean you just extended your layer 2 network connectivity across the different network to avoid any router coming in between two hosts. Just like these are the different hosts and they are connected across the with the multiple routers, but you want to make a tunnel that will make the layer 2 connectivity across, just like VPN. So you just if you study this VXLAN, you will get the idea how this is working.
okay. So basically,
So
the concept here, uh, VXLAN tunnel. So
you
both
see
are,
this you see this diagram, this VXLAN tunnel. So there are a lot of routers coming in this cloud, but these two networks are communicating with each other with their own network routing protocol.
and both are the
They are
same,
not
right?
dependent on the routing that is coming in between these routers or in the cloud.
In this, both are the same IPs or different IPs?
No, no, no. Every time whenever you are making site-to-site VPN or VXLAN, or both side will have the different network. It will do the routing. That's why a static route is added in each worker node to route the traffic. So just if you just look some videos that how VXLAN working, you will get the idea how VXLAN is working actually.
Yeah, actually, some days before I got this project, but unfortunately, yeah, there is something. But yeah, I will initialize once again. I will study.
No, actually VXLAN is no one using in VXLAN is only used for this purpose. In your practical life, if you other than this, this Kubernetes communication among different network, you will use some different protocol. You will use IPsec VPN or SSL based VPN to make the layer 2 extension across your different connectivity.
Okay, my last question, Asimir, is if
Yes.
you go back to the diagram, if
Yes,
I do not use VLAN for both
yes,
networks, and
yes.
I just put static route here. For example,
Mm,
in this in this workstation node, or that is automatically even just IP static route from this source, from the advertising network 10.38.0.0. That is my advertising network, and it will
mm.
out the gateway interfaces means the gateway subnets is 10.32. It will also work,
Yeah, it
but
will
it's
also work. Definitely, definitely it will work. But you first of all need to create a virtual network manually. You did. You define that virtual network as a gateway for this network. You define this virtual network as a gateway for this network. Okay. Now, when you have a layer 2 device in between these two devices, then your formula is 100% workable. But when there is a router in between, but there are 10 routers coming in between these two hosts, how do you will define the static route? You don't know what static routes
Okay.
you will use. That the ISP will, how many, if you are using public IPs for host, both hosts, that will fail.
Means this is the replacement of the routing table in layer 3. We are using here in the layer 2 VXLAN.
Yeah, there is layer 2 VXLAN.
Very excellent. Oh, oh, very, very good. Very, very good. Jazakallah
So
khair. You
this is
complete. Very good. Very good.
you got the idea.
Yeah.
Actually, why this name is LAN?
Okay.
VXLAN mean virtual
Yeah.
VX mean extendable local area network. You are extended your local area network across the different
Very, yeah. This one.
from the ISP. For example, your worker node is in one worker node is in one region of AWS, another worker node in another region of AWS. Both are having different IPs and lot of routers are coming over the internet. So VXLAN will just make a seamless, just like it is both worker nodes are connected with the simple layer 2 virtual switch, with simple layer 2 switch.
Weird. Weird. Very good. Got the idea. Thanks. Yeah. Yeah. Thank you, Hassan.
Okay. Any other question?
Okay. Thanks. Thank you. Yeah. I want one more. You
Yes.
show in there is a 2/2. So in all the core and the etc that is 1/1. We were 2/2. Why this have the two network there? You showed some
Anyone,
command.
anyone,
Yes.
anyone would like to answer this 2 out of 2? 2 out of 2 mean this pod contains two
This pod contain two container.
two
Okay.
container. Two
Okay. Okay.
container are demanded and two are up and running. Sometimes you will see here 1 out of 2. It's mean one container inside the pod is running, second is down. Sometimes you will see here 0 out of 2 or 0 out of 1. And we also saw this when we set up this cluster. This core DNS was 0 out of 1. At that time, we have not noticed. But at that time, this core DNS pod was not coming up because this pod was demanding IP from the virtual switch. A virtual switch we have not provided. So that's why this pod was down. When we set up this whole networking technology in the both worker nodes, the pod got the IP and the pod got up.
So this mean W2 in the first they have the two pods, right? In the third line, the 28 DC
No,
port.
yeah, this is I am only querying the one namespace. You can query all the namespaces with the minus capital A. So now you can see in the default there are 4 pods, and these are all in kube system pod namespace. So these are all then hyphen O wide. If I do, I can see which worker node contains which pod. Okay, so this is 32, 38, 32, 32, 38, whatever the virtual switch is providing the IP.
A pod and container is the same thing.
Yeah, pod, we will use the word pod because a pod will contain multiple container. So let me just explain this one too quickly. For example, this is your pod, okay? And this pod contain 2 containers. And this pod is getting the IP from this VNet virtual switch, okay? So this pod will get a single IP. Just like in our case 10.32 0 dot I think 4 we got.
Pod.
Okay, so this IP is allocated to both container. Both container has the same IP. I will show you in further classes. So actually IP is going to pod, and then both container are getting the same IP. Or we can have multiple containers inside a pod. So all the containers will get the same IP. So now you will say that why IP conflict is not happening. because the pod is responsible to manage the IP. Container is not responsible. Okay. Okay. So yesterday I gave you the idea, the container runtime interface we use, and we use a Docker. If I show you this diagram, we use the Docker CLI command line to interact with the container D. But now we have Kubernetes. So what Kubernetes is actually using down the line. So there is a tool on each worker and master node, CRICTL, PS. So this is a replacement of your Docker command. It showed you what containers are actually running on this worker node. If I go to this worker node, CRICTL, PS, you can see these many pods are running. Actually, the container, in fact, the container. So actually, our one pod has one image ID is given, image name is not given. If I type here images, so when we want to bypass the whole Kubernetes cluster and we want to talk directly with these pods, we don't want to talk with the API and then the kubelet and with this way. When we want to talk with this way, we will use the kubectl command. But if when we are going to directly interact on the worker node, this will also use for the troubleshooting purpose. If your API is dead, then how you will interact with your cluster? In that case, you will do the troubleshooting with this command. You will directly interact with your containers. So for example, your API is dead. So how I will know my API is up and running? So CRI, CTL, PS command will show me the VNet is VNet, a proxy, and API. API is running. Okay, and in that case, I can also run if I do --help. You know, it will show me the logs, the PS. I can directly run the container. I can stop. I can restart. Okay, I can get the status. And so actually podman was just giving us the podman ps command. PS is there, but there is also a podman pods command. Sorry, a CRICTL pods. In these pods are running. So I am without any authentication directly landed to the worker master node, and I directly query to the pods. I bypass this whole path. This whole path I bypass. I am directly working at this layer, container runtime interface, that is CRI/CTL. So this will use in the troubleshooting. But as a Kubernetes administrator, as an end user developer, you will use kubectl get pods.
Okay, if the pod has 10 containers, then the VNet will be increased like 10, right?
Yeah, well, because here you can see the VNet. Each VNet has two container. Okay, let me show you. On which worker node? Hyphen O white.
Yeah, worker node 2.
So now worker 2. Let me go to the worker 2. Worker 2. Here this is the pod
Yeah, I
for the
saw.
VNet. Okay, this is VNet 28BC4. 28BC4. Okay.
Hmm.
Now when I will run pod CRICTL PS, it will show me an additional container running. It is only PS is also showing me the pod. For the container, I think there is some different thing.
Yeah,
1, 2, 3, 4,
you
5,
run some
6.
command. I saw there is two container
No, no,
IDs
no,
was.
no. It is also showing the pod, but the output is minimal. We need to do a --help. We can directly see what containers are running.
Yeah.
PS list containers and Pods, list pod and container are same. There is a command, I don't remember right now.
Okay.
But you can see directly what
The
containers are
concept is
running.
this means the containers are means 10 container 10 view IDs 10 views will be created, virtual network will be created for this.
No, each container will have its own network interface.
Oh, got
Yes.
it. Got
Yes.
it.
And
Got
that
it.
container will get the IP from the virtual network.
Virtual network. Okay. Yeah.
So right now this pod actually where is my, I think yes, this pod is responsible to provide the IP on master one. This pod is working as a virtual switch. This pod is working as a virtual switch. Okay, so I think we are good for today. We just understand the installation of the cluster. We understand the basic networking concept and the core component, how they ran, how the IPs are allocated. So any other question if you have?
Yes, I have a question.
Yes.
We use ViewNet instead of Calico. Is it any specific reason?
No reason. You can use Calico, you can use Cilium, you can use any other plugin.
Which one is better?
All have pros and cons. You can see the documentation. Each this network plugin is providing different functionalities. But this
Okay.
is the core functionality we discuss, that it will provide the IP, it will make the VXLAN, VXLAN tunnel. This is a core functionality for all the network interfacing, but there are some advanced things just like maximum transmission unit, pod-to-pod bandwidth control, and communication to the external network. Stuff like this, different plugins are providing different functionalities.
Okay, yeah. Are these recoverable if they got unhealthy?
What got unhealthy?
ViewNet networking.
Yes, you delete it and you can set up the new plugin. I will uninstall this. Actually, this ViewNet is running as a kubectl get. It's actually running as a daemon set, DAEMON. Daemon set we will discuss, but right now I just want to show you system. Yeah, actually this ViewNet ran as a daemon set. So it created, if I delete this kubectl, delete the daemon set, the ViewNet, it will delete this from this, and you can install some different plugin. Get pods. It is terminating, you can see. So I will only get pods from -n cube system namespace. Sorry, -n. It is terminating. It will take some time to terminate. Then you will see kubectl pet nodes will not be in ready state.
If they
And you can deploy your new network plugin.
Okay, one more question. What if we want to change the core IPs? Like
Which core IPs?
Your system IP. If we need
host machine IP.
Yeah, host machine IP. If we
change
need in the production
Hmm.
environment, we occasionally need to change our core IPs. What can we do?
No, core IP. Which core IP? There There is a CNI IP and there is host machine IP.
Your host IP.
Host IP, you simply change and restart all the containers.
We can automatically all the things got
Maybe it will. You need to change some configuration, just like get config map -n cube system. So as a cube system, you can get the I think there is this config map that contains get config map. Cube Adam. I don't remember exactly if that will change the point of your API. You can see there is some configuration in your configuration. Then you need to in your admin.conf file.
I think we need to change it in kubectl.conf.
No, not in the etc cube Kubernetes kubelet.conf maybe. In the Kubernetes here you have to change because the kubelet is interacting with the API.
If we just change it here, we can good to go further.
Yeah, we can change it. Here and all the worker node also, because kubelet, if you see systemctl status, kubelet is the service running and systemctl status container D service. These two services should be up and running. If these are down, it means your cluster is not in good state.
So then what about the authentication token which we got from after running kube init?
Authentication token is working fine. What is question for authentication token?
Authentication token remains the same.
Yes, authentication will remain same. It does not make any change for the token.
We can use the same token to join again the worker nodes.
No, in the token, you will just change the IP. You can regenerate the token with this command. Cube Adam token create print join command.
Can we list the token as well?
Yes, I'm showing you. This token is generated. Yes, you will get the new IP here. Just copy this token and you can put this token on new worker node.
Thank you.
Any other question? Okay, so we are good for today's session. So if you don't have any question, we can close the session.
Yes, I think enough for today. We will start inshallah next week.
Okay.
Thank you so much.
Thank you so much.
Thank you, sir. Allah Hafiz.